Hello everybody. So today I will talk about calculus. The topic today is about application of derivative. So now I will show you the answer. A right circular cylinder is inscribed in a sphere if its volume is a maximum. So now I will show you the answer. We have the sphere in here and the cylinder that should be like this. So this cylinder inside the sphere, so we need to do the dotted line in here. So we know that this diagonal that will on the center of the sphere. So I will put about capital R in here and capital R in here. The small r of the cylinder should be in here. They should on the same line, so this should be in here. And the next one, this is about the height. So the volume of this cylinder, that should be about R square B H. So if we look carefully about this one, we have triangle A, B, C, the right angle at angle B. We can use about Pythagorean theorem. So that should be about H square plus 2R square equals to 2 capital B 2 capital R square. And you must know that capital R in here, they are given, because if they given the radius of the sphere, we can find the maximum volume of cylinder in here. So this is about the constant number. So we got about H equals to the square root of 4R square minus 4 small r square. So we put this one go in here, and now we have the equation with in terms of r in here. We have r square b and the square root of 4 capital R square minus 4 small r square. Now we have number 4 and number 4. The square root of number 4, you got about number 2, so we put number 2 in here. Now we need to use first the derivative of the function. So we got about, we do first the derivative of r square, so you got about 4r b with the square root. Next, we do first the derivative of this one. So we got about the square root in here with negative r, because we have number 2 and number 2, but they simplify in here, so I just eliminate. Now we need to put first the derivative of the function equals to number 0, because we want to find about critical point. So we put this one equals to number 0. So we need to simplify r in here, b in here. So you got about 4 multiplied with the square root. This one simplify. Oh, we simplify number 2 too. So we don't have number 4, we have number 2. So this one you got about negative r square over the square root equals to number 0. So we put this one on the right. This one we change for positive. So we have two square root, they multiply each other. And we have 2 capital R square minus 2 small r square equals to r square. So we put this one on the right. And we got about r equals to the square root of 2r square over 3. So we got the simplified, that should be about r, the square root of number 6 over 3. Now we return back to this one. We can use about r equal to this one, and we can find the volume in terms of capital R in here. So that should be about, we put this one go in here and this one go in here. You will got the maximum, that's about 4 capital R over 4 capital R to the power of 3 square root of number 3, and we have b in here over 9. Or you can find about this one another, that's about r square equals to 3r square over 2. So we can find about the height. The height we just have in here. So we can find the height so that they can got the maximum value of the volume. So we put r square, that's about 3r square over 2 go in here. and you will got about 4 multiplied with 3r squared over 2 minus 4r squared, and we got about r multiplied with the square root of number 2, and this one you can get the volume in terms of the small r in here. That should be about v equal to r to the power of 3b square root of number 2. That's the end. Thank you for watching.